Here we have a couple more examples over compound interest. We invest $500, that's our P, at a 5% interest rate, so R is 0.05, compounded monthly, N is 12. It says how long will it take for your investment to reach $2,000? So this time we know how much we want to end up having in the future, that's our value of A. We don't know how long, so we don't know T. We're trying to figure out how many years until we get to $2,000. So I'm just going to start by substituting in everything that I know. Again, we're compounding monthly, not continuously, so we're going to use that first formula. So we have A is 2,000 equals 500 times 1 plus 0.05 over 12 to the power of 12t. Again, I don't know t, so I'm going to leave that variable as the letter. Now we're solving for a variable that's in our exponent. The first thing that I'm going to do is divide by 500 on both sides. 2,000 divided by 500 is 4 equals, and then I'm going to simplify what's on the inside. So we have 1 plus 0.05 over 12, which is 1.004166 blah, blah, blah. So we've got that 1.0041, I'll call it 67, to the power of 12t. When I'm doing this in the calculator, I'm not going to actually round. I'm going to keep this entire long decimal in my calculator. I'm not going to get rid of it. Now, since our variable is in the exponent, we need to change this to a log. So our base is that 1.004 blah, 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 004. Our answer is 4, and that's equal to 12t. This left side, I can use the change of base formula. So now we have log of 4 over log of 1.004167 blah, 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 equal to 12t. So I'm going to put that in my calculator. And I got 333.4032869. And I'm going to divide by 12. And I got 27.78. Now when we're talking about years, we're going to use whole numbers. We're going to round this up to 28 years. So this is going to take 28 years to go from $500 to $2,000, which is kind of a long time. Try and get a better interest rate. Kristen invests $6,500 in an account with an interest rate of 12%, so R is 0.12, and it's compounded continuously, so we're going to use this second formula. How much money will she have in 6 months? Now, T, that's the time, but T has to be in years. So how many years is 6 months? That's half a year. So I'm going to put T is 0.5 or 1/2. So using our compounded continuously formula, we're looking for A. We need to know the amount of money in a certain number of years, equals our principal, which was 6,500, times e to the power of 0.12 times 0.5. Now again, our variable is all by itself, so this is stuff that we could just type straight into the calculator. And I got 6901.94. So in half a year, Kristen made about a little over $400. That's not too bad. Could be better, but it's not bad. Let's look at one more example. Still same situation with Kristen, but this time it's asking how long it'll take for her investment to double. So that means we started with 6,500. We want that to double, so that means we want to end up with 13,000 equal to 6,500 e to the 0.12 t. Again, we don't know t, so I'm going to put that variable there. When I divide by 6,500, I'm left with 2 equal to 0.12 t, e to the 0.12 t. Then again, I'm going to change this to a log. My base this time is e, so we can use the natural log. Inside of that natural log, I'm going to put the 2 and the log is equal to the exponent, which is 0.12t. Then I'm going to figure out natural log of 2 in my calculator and divide that by 0.12, and I get 5.7762. But since we're talking about a number of years, I'm going to round up. So t is approximately 6 years.